So what I'd really encourage you to do is to get quadrant 1 really well memorized from your unit circle. And in particular, I like to memorize one of them really, really well. My favorite one to memorize is sine of pi over 6. I have sine of pi over 6 as a half. That way, if I get sine of pi over 3, I'm like, oh, it's not a half, so it must be the root 3 over 2. If I see a cos of pi over 6, I'm like, oh, it's not a half, it must be the root 3 over 2. So I remember 1 really, really well. And then if you know quadrant 1 really well, then if you get a question like this, what's sine of 7 pi over 6? In your brain, you already know your reference angle is pi over 6. And since the 7 is one more than the denominator, we would know that it's in quadrant 3. So since I know that sine of pi over 6 is a half, sine of 7 pi over 6 also has to be a half, but because it's in quadrant 3, sine is negative in quadrant 3, it would be negative a half. So we know quadrant 1 really, really well, and that serves us to be able to figure out the other ones really well. Okay? Not bad if you have your, you have your quiz handy at the beginning, because you're like, I want to double check. So try to think in first in your head, then look at your quiz to be like, did I get it right? Okay? And then over time, you're just going to be able to get them from memory. So here, tan of 2 pi over 3. I know that this is going to be in quadrant 2, and I know my reference angle is pi over 3. So I think, what is tan of pi over 3? It's the square root of 3. And because it's in quadrant 2, it would be negative. My strategy for remembering tans, pi over 3 family, always goes with root 3. Pi over 6 goes with root 3 over 3 because 3 plus 3 is 6. That's what I use to remember it. Seems to work for me to get the answers quickly. Cos of 7 pi over 4. I know my reference angle is the pi over 4 family. And 7 pi over 4 is in quadrant 4. So I know that cos is root 2 over 2. Then I think in quadrant 4, oh, it's going to be positive, so it stays root 2 over 2. And then we can do all of the other ones as well. Secant, cotangent, cosecant. Okay? We're going to start off with the same kind of things. You know the reference angle, it's pi over 4. And this angle is negative. What quadrant will it be in? Quadrant 4, because you're going in the negative direction. Then some of these ones off to the side, I'll show you what I'll be thinking. Because secant is related to cos, I'm going to think about cos of negative pi over 4. Notice the angle doesn't get flipped. Angle stays the same. So our angle stays the same, and then I'm like, well, it's the same reference angle, it's quadrant 4. I know that cos of pi over 4 is root 2 over 2. So secant of negative pi over 4 will equal the reciprocal. So the answer is what you flip. Now, you might remember from our special triangles that we had originally written this as 1 over root 2. So another way of writing 2 over root 2 is root 2. Important to see those things because if it's a multiple choice question, it might be in one form or the other, and so you have to manipulate. Okay? You do not need to rationalize the denominator except for multiple choice questions in order to make it match up with what the answers are available. So that's what I would think of. I would think, I know what cos is, so then if I know what cos is, secant would just be the reciprocal. Same thing for this one. Again, radians are really nice for determining the reference angle. The reference angle is pi over 6. And this one is going to be in quadrant. It's going in the negative direction. It's in quadrant 1. Off to the side, I would think about tangent. And again, the angle does not change. Pi over 6 family for tangents, root 3 over 3. And again, you might remember that we had originally written that as 1 over root 3. And it's positive because it's in quadrant 1. So then when I go to cotangent, I could either write the reciprocal this way, or if I took the other one, it would just be the square root of 3. So one of the reasons in grade 12 they say don't worry about rationalizing the denominator is because in some ways with the cotangent, the 1 over root 3 is a nicer answer than 3 over root 3. But with tangent, the root 3 over 3 is a nicer answer than the 1 over root 3. So sometimes it makes sense not to rationalize, and sometimes it does. So they accept either one whenever you do a question. And cosecant of negative pi over 2. The axes family, I don't really write down a reference angle for that. Technically, the reference angle would be pi over 2 in this situation. And the axes family is kind of interesting because it's not really in a quadrant, right? It's right on the, it's like, is it in quadrant here, negative pi over 2? Is it in quadrant 3 or is it in quadrant 4? Is it in both? Is it in neither? So we don't really, with the axes family, just think about your unit circle and the axes family, right? You've got these 4 points, and they're really easy to remember the coordinates because the radius is 1. So where is negative pi over 2 on here? Well, negative pi over 2 would be down right there. I can label that point. The x coordinate would be 0, the y coordinate would be negative 1. Now I'm dealing with cosecant, so what would I think about? I would think about sine. And sine is which coordinate?
Negative 1.
Your y coordinate, so that's negative 1. So technically, I mean, you can write it this way, 1 over negative 1, which is just negative 1 as well. But we do the reciprocal, right? So if it's negative 1, we would do 1 over negative 1, which is still going to be the same number. So it's one of the points where both sine and cosecant are the same. So we did these all individually. What does the exam like to do? The exam likes to put 2 or 3 or 4 of these together and make it like a 3-mark question. So this would be a 3-mark question on the final exam, and they put 3 of them together. And so I'm going to, for my work, I'm just going to put answers in here. I'm color coding it because off to the side, I'm going to show what I'm thinking about. And we'll start with the blue. Because if you start doing too much thinking underneath here, I'm going to tell you your math is going to start to get messy and you're going to start making mistakes because you're going to put wrong things together too early. So I'm going to do my thinking off to the side. And once I know what secant of 11 pi over 3 is, I am just going to write in the answer for it. So for secant 11 pi over 3, I'm going to think about cos of 11 pi over 3. I know the reference angle is pi over 3. And now I just have to figure out what quadrant it's in. Okay? And we might use that idea we were looking at yesterday where we change this to a mixed fraction. And if I write 3 2/3 pi, 3 pi is going to be on your negative x-axis. We're going in the positive direction. 2/3 is more than half. I know this is in quadrant 4. Okay? Again, the one that I have memorized the best in quadrant 1 is sine of pi over 6. That's a half. Now I have cos of pi over 3. I know that that's a half. Because my pi over 6 for cos would be root 3 over 2. So that means my pi over 3 for cos would be 1/2. And then in here, I write the reciprocal. Next, we'll go to green. What am I going to think about? Well, for the green one, I know my reference angle is pi over 4, negative 5 pi over 4. And you're going to see me start to take out a unit circle so that you can think about it and see it here. Okay? Negative means I'm starting always at the positive axis, but I'm going in this direction. Okay? Positive 5 pi over 4 is on your pi plate. Do you see that? It's in quadrant 3. Positive 5 pi over 4 is in quadrant 3. So if you went 3 quadrants in the negative direction, do you see that you would end in quadrant 2? So I think about positive angles going, okay, 5 pi over 4 would be in quadrant 3 in the positive direction. So in the negative direction, it would be 1, 2, 3, quadrant 2 in the negative direction. So I know that this is quadrant 2. So what does that tell me? I know that pi over 4 is root 2 over 2, and because it's in quadrant 2, it's going to be negative. And then in purple, it's tangent. I know my reference angle is going to be pi over 6. For the quadrant, 23 is 3 and 5/6 pi. And again, going in the positive direction, the 3 would be on, and I can show it here, the 3 would get me to the negative x-axis, and 5/6 is more than half. It's going to end in quadrant 4. Tan of my pi over 6 family, 3 plus 3 is 6, is root 3 over 3. And in quadrant 4, my cast rule says tan is negative. On the provincial exam, they give you 1 mark for each color. And in each color part here, like the 2 over 1, they give you a half if you have the numbers right, and a half, really generous, if the sign is right. So if you wrote root 2 over 2 but forgot the negative, you would lose a half a mark. If you had the negative but had the root 3 over 2, you would still get half a mark for the negative, but lose the mark for the ratio. And so you get 1 mark for the blue, 1 mark for the green, 1 mark for the purple. This is only worth 3 marks. So at this point, you have 3 over 3. But if you stop and don't write your final answer, they give you an E1. The E1 error is you just decided not to write the final answer. It's kind of a funny error, because usually people are like pretty good at writing the final answer. Okay? You can also make a mistake in writing the final answer, then you just get a half a mark off for not being able to add or subtract or multiply. Okay? How do you multiply fractions? You multiply the tops, you multiply the bottoms. If things can simplify, like 2 divided by 2 is 1, I would do that right away. We have to remember that a negative times a negative is positive. How do you multiply square roots? Right? Square root of 2 times square root of 3? Are you allowed to do that? Can you do that? What's the answer? So from grade 11, multiplying square roots, you can multiply the insides. Adding the square roots, you cannot add the insides. So square roots are not normal, but it seems normal in this case, because multiplying square roots, just multiply the insides. And then on the bottom, I'd have 1 times 3, or my final answer would be root 6 over 3. There is a fair number of these on the multiple choice in your take-home quiz, where you have to do your unit circle for individual things, and then put your answers together to get a final answer. If you know your pie plate on the final exam, these are easy questions to get full marks on. And it's a lot of marks. 3 marks that's not very much work for 3 marks on a question, which is kind of nice. If you forget it's a unit circle question, oh my goodness, then you lose all your marks because you try something else. So, whenever they're saying find exact values and those values are on your pie plate, it's probably a pie plate question. And now that we know our pie plate, we can take grade 10 and 11 solving questions that we used to have to use our calculator for by doing sine inverse on our calculator. Now we can do it just in our head using our pie plate. How does this work? Well, first, I'm going to do it like I didn't know my pie plate and I was in grade 10. If I was in grade 10, this would be like this. Agreed? And you still need to know grade 10 math because they're going to give you ones that aren't on your pie plate. But if this was grade 10 math, what I would do, I'm going to use some grade 10 and some grade 11. I would be like, I need to find my reference angle. It's a little bit, maybe more, a little bit more like grade 11. In grade 11, how do you find your reference angle? You do sine inverse of, something that is very important. Reference angles always deal with an actual triangle. So when you're doing your reference angle calculation, that root 3 over 2 in your calculator has to be positive. So I go to my calculator and I go, make sure I'm in degrees. You will have to switch back and forth between radians and degrees in grade 12 depending on what the question is in. And I go sine inverse of the square root of 3 divided by 2, and I get 60 degrees, which you're like, now you've done your unit circle, you're like, I'm not surprised, I knew that already. But in grade 11 and grade 10, you would have found your reference angle to be 60 degrees, and then your actual answer, because of your cast rule, sine was negative. Sine is negative in quadrants 3 and quadrants 4, so you would use your reference angle and say 180 plus 60 and get 240 degrees. And you would do 360 minus 60 and get 300 degrees. That's grade 11. You would use your calculator. Now that we're in grade 12, this question shows up on a non-calculator. What you have to do is you have to go, is my y coordinate ever root 3 over 2 on my pie plate? Yes. Which family is it? And again, this is where if you have one memorized really well, like I said, I memorized sine of pi over 6 is a half. So when I see this, I'm like, oh, it's not pi over 6. Therefore, it's pretty easy for me to figure out that my reference angle is pi over 3. Because the root 3 over 2s and the 1/2 either go with pi over 3 or pi over 6. The root 2 over 2s are easy because they're both the same for cos and sine, and you're going to find that you remember that's pi over 4 easier. But these are the ones that go like, oh, which one is it? So that's where I say if you memorize one really well, you're going to be able to find your reference angle. And now we're in radians, so instead of writing 60 degrees, I found my reference angle is pi over 3. Then, just using my pie plate, I think, okay, what's my pi over 3 in quadrant 3? In quadrant 3, it's always one more, or pi over 3. What's my pi over 3 family in quadrant 4? 5 pi over 3. And that's all the work you do. Like, technically, this on the exam they'd say, we're pretty sure you could figure out the reference angle in your head. If you didn't write that down and just wrote the answers, full marks. So there's very little work that needs to be shown for this question. Because you can just see it, and from your pie plate, say what the answers are. -1. Okay? Again, in grade 10 and 11, you would have to go to your calculator and do cos inverse of -1 and use your cast rule. Now that you're in grade 12, -1 is on your axes family. Cos is your x coordinate. When is your x coordinate -1? What's the angle? And all you would have to do is write the answer. Right? Because if we think about on our unit circle right here, our unit circle, that point right there, that's the only place my x coordinate is -1. And the big idea of points on the unit circle, x coordinate is cos theta, y coordinate is sine theta. So in this question I see the -1, I know that that's my axes family. I see cos, so I know I'm looking for x coordinates. And I can just write my answer. Tan of theta equals -1. So again, is tan ever 1 on your unit circle? What family? Pi over 4. So you already know your reference angle by knowing which family it belongs to. Then your cast rule, right? And again, some of these things, you don't have to write them down if you know you can visualize them in your head. But tan being negative is going to happen in quadrants 2 and quadrant 3. So then I can write my answer right away. What's my pi over 4 in quadrant 2? 3 pi over 4. What's my quadrant pi over 4 in quadrant 4? 7 pi over 4. Okay. So in this unit, you're gonna, like, when we do in-class quizzes and when we do our test, I will give you a tiny little blank unit circle. And you might color code your different families. But you're gonna find you might just fill in quadrant 1. You don't have, like, you'll get a blank one and say, hey, you can write a few things down. You might just quickly fill in quadrant 1. Because you're like, if I have quadrant 1, the rest is easy to decipher. I can figure out the rest. And now we're seeing how, hey, if I know it's -1, I see in quadrant 1 here that tan of pi over 4 was 1. Now I can take that to figure out it has to be in quadrant 2 and quadrant 4. What are my answers? And eventually, hopefully, right, I've got all quadrant 1 up here. I don't need to write it down. I can just visualize quadrant 1 and I can get all of my answers quickly from that. Secant theta equals 2. Non-calculator question. Any of the reciprocal ones, change it to its reciprocal. The angle doesn't change, but the ratio of 2 would switch to 1/2. In quadrant 1, is your x coordinate ever a half? And again, this is where I use the strategy. I have one of them memorized really well. If I know that sine of pi over 6 is a half, now I'm dealing with cos. It's not going to be pi over 6. I know my reference angle, therefore, has to be pi over 3. What quadrants am I looking in? Think about my cast rule. Cos of theta was positive, so I'm looking in quadrant 1 and quadrant 4. So I can write down my answers. Quadrant 1, it would be pi over 3. Quadrant 4, it would be 5 pi over 3. And again, that's all the work you need to show now. Don't have to go to our calculator unless it's a value that's not on your unit circle. Then we still have to know how to go to our calculator, do cos inverse of the positive value to find our reference angle, and use your reference angle in the right quadrants. Sometimes you'll go pi plus your reference angle, pi minus your reference angle, and so on to find your answers. So we'll get some that are mixed that way. If this was a grade 11 question, you would first get sine theta by itself. Are you all right if I do this all in one step? Subtract 1 on both sides and divide by 2? So I'd get negative 1 over 2. And I would say, is a half ever my y-coordinate on my unit circle? Yes. What's my reference angle? Well, this is where it's really handy that the one that I memorized really well was sine of pi over 6 was a half. Now I see that this is going to be a reference angle of pi over 6. I would think about my casserole. And I would notice that since it's negative, I would be looking at quadrants 3 and quadrants 4. And so my answer for theta is, what's my pi over 6 in quadrant 3? 7 pi over 6. What's my pi over 6 in quadrant 4? 11 pi over 6. And part of what makes trigonometry difficult in grade 12 is because each of these questions requires you know your cast rule really well, reference angles really well, unit circle really well. Any one of those mix up and you're going to get your answers wrong, right? But knowing them really well can make some of these questions feel like they're not too bad. That's why we had to memorize our unit circle, and I require you to get 100% on it, because you're going to use it so much in this unit, and we also use it in the next unit as well. And on the exam, the unit circle kind of area, you should have 8 units this year, but the 2 trig units count for about 20 to 25% of the exam. It's more on those 2 units than any other 2 units. Now we go to grade 11, and we'll start solving quadratic trig functions. So first of all, a review of grade 11. Could you solve a quadratic equation? How do we solve quadratic equations? Review of grade 11. You always had to make one side equal to 0. You remember that? Very important that one side's equal to 0. And then you could either factor or the quadratic formula. You also learned to completing the square method, which you won't use, because if you wanted to use that, you'd probably say, I'll use quadratic formula, or I'll use factoring. Those will be your easier methods. Can we factor this? Right? This has a common factor. If it has a common factor, you can take that common factor out. And the whole reason, just to review, the whole reason you factor is because as soon as you change this to multiplying, you just made something very powerful. And this is why it's so important one side is 0. If I put 2 numbers in my head and I say I multiplied them together and the answer was 0, could you tell me what one of the numbers is? If I multiply and the answer is 0, one of them has to be 0, right? If I'm adding or subtracting and the answer is 0, and I have 2 numbers in my head, you could guess forever. I could pick like pi and negative pi. you'd probably start guessing real numbers and you're like, oh, come on. Right? Or I could pick a decimal with 8 decimal places. You would probably never get it. You would definitely give up before you got the right number. This would be super hard to guess. But as soon as it's 0, one of these has to be 0. So what we often draw is we draw a line at the multiplication and say, well, if this one's 0, then x would have to be 0, and guaranteed that would work. If the second one was 0, what would x have to be? 1. That would make the second one 0. And if either one of them is 0, it's equal to 0. Now, we're going to do that is a review of grade 11, factoring, making one side equal to 0. But now our quadratics are going to be on this side. Notation-wise, if we want to square cos or square sine or square tan, we put the 2 in between the cos and the theta. Because we could write it like this, but mathematicians don't like writing extra brackets. It's like wasting time for them. But then the problem is if you just take off the brackets and write it like this, it's a little bit ambiguous. Is just the theta squared or is the whole thing squared? So when we want to write the whole thing squared, we would put the squared in between the cos and the theta. If we wanted just to say theta was squared, we would write it afterwards. So just like here, I notice I have a cos theta in common, and I would factor that out. And now that I've factored and it's equal to 0, I would split it here. And it's either that this one is equal to 0, in which case cos of theta would have to be 0, or this one is equal to 0, in which case cos of theta would have to equal negative. Oh my goodness, that's huge. Positive 1. And now it becomes a pi plate question. You see this is your axis family? Where is your x coordinate equal to 0? Pi over 2 and 3 pi over 2. Axis family question again. When is your x coordinate equal to 1? 0.
And pi, 2 pi.
And 2 pi. And one thing you're going to be, like, your textbook is notorious for doing this. And then if you wrote 2 pi, they would say, we have to take off a half a mark. Because in the blue, there's no equal sign. So always reread your question. One of the things in rereading your question when you're done, you're going to double check what domain was given to me. Because you're going to get some tricky domains. Right? They could ask this from 0 to 2 pi. Sometimes they ask it from negative 2 pi to 2 pi. Sometimes they say, let's go from 8 pi to 10 pi. And then you have to figure out what would be coterminal. So that idea of coterminal angles at the beginning comes back over and over again. So again, what makes trigonometry difficult is every question has about 5 or 6 concepts that you have to know really, really well. And as we're doing these questions, we'll get chances to review each of those concepts over and over again. Sine squared equals negative 3 over 4. Right? If you're stuck and don't know how to solve it, just think, well, what would you do? Oops, minus. What would you do if it was just an x? And you had to solve for x? How many of you think you would just get the 3 or 4 over on the other side and then square root both sides? So then if you can think what you would do with the x, we'll do the same thing when it's sine squared, cos squared, tan squared. I'm going to get the sine squared by itself. And then I'm going to square root both sides. And I'm going to make a mistake that you guys always will make. There we go. And technically, that root 3 over 4, that's the same as square rooting the top, square root of 3, and square rooting the bottom, which happens to be 2. Anybody see the mistake that I made? It can be, when you square root both sides, you must add the plus or minus. In this case, usually if you forget the plus or minus, they take off a half a mark. In this example, you would lose a whole mark if you forgot the plus or minus. Because is root 3 over 2 on your pie plate? Yes. What family?
Pi over 6.
Careful.
3.
Sine pi over 6 is a half. So this will be pi over 3 family. Then our answers will be, well, because of the plus or minus, it's going to be all 4 quadrants. So we're going to get quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If you forgot the minus sign, you would miss 2 answers. Each answer is a half a mark. That would cost you a whole mark in this situation. Quadratic equations. So if you had this, in grade 11, what would you do? It's already equal to 0. That's good, right? Quadratic equations, we need one side equal to 0. And then you would either factor or use a quadratic formula. Factoring's always faster if you can do it. If you can't do factoring, you might want to use your quadratic formula. Okay? I'm going to show you a couple things with both to help review factoring and to help review quadratic formulas. Okay? So first of all, if you can factor, this is what it would look like. Factoring is the opposite of multiplying out. Now, if you multiply this out, you would multiply this, 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 and this. And in English sometimes, and you might have heard this in your class, sometimes in English we use an acronym. Because you multiplied your first ones, we put an F there. Because you multiply the outside ones, we put an O there. You multiply the inside ones, we put an I here. And you multiply your last ones, we put an L there. And we tell kids in grade 9 and grade 10, hey, an easy way to remember that you have to multiply all of those is think of the word FOIL. You multiply your first ones, your outside ones, your inside ones, your last ones. But an analysis of this is really important because your first ones will always be this one. Your last ones will always be this one. And your outside and inside will get combined for the middle one. And knowing this can make factoring really, really easy. Even with one, like generally speaking, when there was a number in front of the first one, you're like, ooh, those ones are harder. But I'm going to say if an analysis of this can make these easy as well. Okay? So what I recommend with factoring is you look at your first one and ask yourself, what could give you 2x squared? And if there's only one option, life is really easy. In this case, there's only one option. What's the only thing to get 2x squared? If you had to have an x in both, right? If you had to have an x in both and you're only allowed to use whole numbers, it has to be 2 and 1. Well, that was easy. So if it can be factored, there's no choices there. Then I look at my last number next. What are my choices there? This is actually the easiest number that exists. It's a 1. If you're going to use whole numbers, what are the only 2 whole numbers that get you 1? It would have to be 1 and 1. Now notice I didn't put the signs in yet. Just dealing with numbers. Because technically, you see, it could be +1 and +1 or -1 and -1. Now I'm going to look at my outside and inside. My outside makes 2x. My inside makes 1x. I need a -3x. Does it make sense that I would need a -2x and a -x? And using that strategy can often get you to factor very quickly. Okay? Once you are done factoring, always double check it by multiplying it out again. Do my first ones, 2x squared, give me this, yes. Do my last ones, minus 1, give me plus 1, yes. Do my outside and inside, give me minus 3x, yes. Always double check. Because sometimes our brain can play tricks and we do an easy mental math error. That double check is really important. Now let's say you felt like everything I tried doesn't work. So then you decide you want to use the quadratic formula. Quadratic formula is on your formula sheet. This year, next year, in grade 12, you'd have to have it memorized for AP Calc. Okay? What do? We plug in negative b. Well, my b value is negative 3. Plus or minus. The square root, negative 3 squared would be 9. Minus 4 times a is 2. Times c was 1. Over 2 times a. Negative would be positive, plus or minus. 9 minus 8 is 1 over 4. Square root of 1 is 1. Anytime this is a nice square root and you're using the quadratic formula, it tells you, good job, you could have factored this. If it's a square root of 4, square root of 9, any nice square root, the quadratic formula is like, you just took the longer way, you could have factored this. If it's a square root of 5, square root of 9, no, not square root of 7, something you can't square root, then your only option would have been the quadratic. Now we can write both of our answers here. If I do the 3 plus 1, you see that you would get 4 over 4? That would give you 1. Notice in our factoring, once I split it here, that's how it gave me x equals 1. If I do the 3 minus 1, you see you would get 2 over 4. 2 over 4 reduces to 1/2. Can you see on this side? You would have got 1/2. If you use the quadratic formula first, and you got the answers, can you see how you could write the factor part? And like pretend you cheated and factored? Like if I know that one of the answers is 1, then I know that one of these had to be sine theta minus 1. And if I know the other answer had to be 1/2, this would have to be 2 sine theta minus 1. So we can factor it with signs as well. Now what happens is when we go to solve, it's not x equals, it's sine theta equals 1 and sine theta equals 1/2. This is your axes family. Axes family ones, I just write my answer down. Where is your y coordinate 1? Pi over 2. Other ones, what's your reference angle? Again, this is where having sine of pi over 6 memorized to half makes this one super easy. I know my reference angle is pi over 6. What quadrants am I looking in? Positive, so quadrant 1 and quadrant 2. And this question has 3 answers. Okay. One of our big ideas from this unit was that sine squared theta plus cos squared theta is equal to 1. Something that's always true. In trigonometry, something that's always true is called an identity. And we have our whole next unit is dealing with more of these. We have a whole unit on trigonometric identities. That's after this unit. But we've learned one already. And sometimes you're going to get a question which says negative 3 sine theta minus cos squared theta minus 3 is equal to 0. And if we translate that back to grade 11, well, that would be like this. And I'm going to choose x's for cos because they're your x coordinate and y's for sine because they're your y coordinate. And we have an issue here. You have one equation with two things you don't know. That's impossible to solve. You could graph it, but you can't solve. If you have two variables, you need two equations to solve it. Do you remember that? And then you could use substitution or elimination. Well, the identity, this hint wouldn't be given on your exam. That would have to be in your head to use that hint. The identity gives you the second equation. X squared plus y squared equals 1. And you could use substitution. Okay? What's going to be easy to substitute? The squared item. Can you see that if I take sine squared plus cos squared equals 1, I could get the cos squared by itself by subtracting the sine squared to the other side. So not only will you have the big idea really, really well memorized, sine squared theta plus cos squared theta equals 1, you will also have rearrangements of it really well memorized. You'll be like, oh yeah, cos squared theta is 1 minus sine squared. Sine squared theta is 1 minus cos squared theta. And now I can use substitution. And in my equation, where the cos squared was, I can put a bracket and I can replace it with 1 minus sine squared theta. Really important that I put brackets because this minus sign is going to distribute to both of those. And what are we going to get? We're going to get a minus 3 sine theta minus 1 plus sine squared theta minus 3 equals 0. And now we only have one trig function, which is like only having one variable. It's quadratic. Because it's quadratic, I would combine my like terms. I would write the sine squared first. Minus 3 minus 1 minus 4. And I would go to factoring. Sine squared, really easy. The only thing that could be first is sine theta and sine theta. The 4 gives us some options. Because it could be 2 and 2, or it could be 1 and 4. Before I write them down, I just pick one. I'll pick the wrong one first. I pick 2 and 2. Can you see your outside's 2, your inside's 2? Does outside and inside ever make 3? Not if it's 2 and 2. But if I pick 1 and 4, outside 4, inside 1, hey, if I subtracted, I would get a 3. I need a negative 3. Does that make sense that I would need a negative 4 and a plus 1? And so if this one's equal to 0, sine of theta would be minus 1. If this one's equal to 0, sine of theta would be 4. And this is still a non-calculator question, even though 1 is not on your pie plate. So normally, if something's not on your pie plate, you're allowed a calculator to find the reference angle. Let's pretend it was calculator. This one, you definitely can see is the axes family. 1 is your y coordinate, negative 1, at 3 pi over 2. I'm going to tell you that you're expected to do this without your calculator, but if you type it into your calculator right now, go to radians, type in sine inverse of 4, what does your calculator say? Yeah, you should always have your calculator along. Anybody do it on their calculator yet? You get an error? Go to your calculator, you try to do sine inverse of 4 to find your reference angle, and you get an error. You have to know that that's an error without your calculator. This side, you have to say not possible. Why? Because if I wrote this as a fraction, it would be 4 over 1. Then if I tried to use SOHCAHTOA and draw a triangle with this, I'd pick one of my angles as theta. That would mean my opposite side is 4 and my hypotenuse is 1. And when you draw the triangle, something should tell you this is not good. My hypotenuse is smaller than my opposite side. Hypotenuse always has to be the biggest. This is impossible. You're right, it is impossible. So anytime you get an impossible value, something bigger than 1, or a negative answer, technically less than -1, you can always write not possible without your calculator because it is impossible to draw that triangle. So this question would appear on a non-calculator part. I've got 2 more to do. Maybe we only get one done. One done today. Do I have this? I know you have only one left in your notes, but I'm going to make one. I'm going to make one up after E for us to do together. And maybe I'll start that off as tomorrow's class. But E would show up on a calculator part. Of your example. And it's quadratic, so I would make one side equal to 0. The 6 makes this harder to factor. One of the reasons it makes it harder to factor is because there's more options. I can't just write, I know it's 2 and 3, or I know it's 6 and 1, because there's more options. Okay? When there's more options, I might say, hey, go to the quadratic formula. Or I might say, in this one, I would still factor because I would look at my last number. Are there lots of options for my last number? No. I know that it has to be 1 and 1. So I'd actually do my last number first, and my first number last. Ooh, confusing. Now, can you see if you do 6 and 1? Your outside 6, your inside is 1. Does that ever make 1? No, it can't be 6 and 1. If I tried 2 and 3, my outside would be 2, my inside would be 3. Would that ever add or subtract to get 1? Yes, so I'm going to write that down. 2 sine theta and 3 sine theta. I need a positive 1. So that would be 3 minus 2, so I'll make the inside plus and the outside minus. I'll multiply the whole thing out to double check that it works, and it does. Are you okay if I do this in one step? What would make this 0? Okay? And in your head, I'm going to write it out. In your head, you're like saying this. What would make this 0? Well, I would have to move the 1 over and divide by 2, right? What you're going to write is just -1 over 2. But you're solving that little green equation. What would make it 0? What would make this one 0? So in your head, you're imagining, I have 3 sine theta minus 1. I want that to equal 0. How would I do that? I'd move the 1 over and divide by 3. Half is on your pie plate. So on these questions, even though this is calculator, they would say, write down exact answers where possible, or use your calculator where not possible. This side, that's your pi over 6 family. It's negative, so it's in quadrants 3 and quadrants 4. The other side is not on your unit circle. So here, we need to find our reference angle by going sine inverse of positive 1 divided by 3. Reference angles are always positive. Make sure that our mode is in radians. And I get 0.340, right? Rounded to 3 decimal places. Two different ways you could do this. You could either round it already, or write the 3 decimal places and put dots saying it continues forever, and I'm going to use all those decimal places because you have to only round at the very end. And so our answer have to be in quadrant 1 and quadrant 2. And to find quadrant 2, if it was degrees, you would do 180 minus your reference angle. Since it's radians, we would do pi minus our reference angle. So I'll go pi minus my answer, 2.802. So we have to be careful that we only round right at the end. Again, to find that quadrant 2, I think about my reference angle, and I would go to find this angle all the way, which is pi, and minus my reference angle, to find the 2.802. This side, move your calculator.